Hello my dear students, I warmly welcome you to CS digital classes. In this lecture, we are going to discuss about one of the important theorem, that is Cauchy's theorem for finite abelian groups. This is the name of the theorem, Cauchy's theorem for finite abelian groups. In the examination purpose, this theorem is very important. Okay, so let's see the first of all statement of the theorem. Let capital G be a finite abelian group and let P be a prime number that divides the order of the group capital G, then prove that G has an element of order P. Okay, so this is the statement of this theorem, Cauchy's theorem for a finite abelian group. Okay, in the name only we have finite abelian group. Okay, so capital G be a finite abelian group, let P be a prime number. Okay, you can take any prime number. Prime numbers are starting with 2, 3, 5, 7. Okay, so if you take any prime number, that if that prime number divides the order of the group G, okay, that is the finite abelian group G, then we have to prove that then that G has an element of order prime. So this is the statement of the theorem. Okay, technically this theorem is the very most powerful theorem. Okay, in the history of finite abelian groups, this theorem is the very most powerful theorem invented by Cauchy, one of the famous mathematician from the Italian. Okay, so and the significance of this theorem is, in this theorem, to prove this theorem, we are going to use that principle of mathematical induction and properties of the cosets and factor groups by using these three conditions. Okay, so we are going to prove this theorem. That's why this theorem has this much of significance. Okay, so let's start the proof of this theorem. Let capital G be a finite abelian group of order n. Okay, so I am taking that order of G is equal to small n. That is taking as equation number 1. Okay, so that is the finite order of the given abelian group. Now let P be any prime number that divides order of G. Okay, so mathematically, okay, you can write P divides mod G. Okay, symbolically you can write P divides small n. Okay, just remember this value, or else you can take this value as equation star. Okay, P divides small n, where n is the order of the group finite abelian group small n. Okay, where P is a prime. సో ఒకటి గుర్తుపెట్టుకోండి, ఒక ప్రైమ్ నెంబర్ ఏదైనా నెంబర్ ని డివైడ్ చేస్తుందంటే ఖచ్చితంగా ఆ డివైడ్ అయ్యే నెంబర్ కూడా ప్రైమ్ నెంబర్ అయి ఉండాలి. ఓకే, ఫర్ ఎగ్జాంపుల్ ఇఫ్ యూ హ్యావ్ 5, ఈ 5 అనే నెంబరు డినామినేటర్ లో ఉన్నప్పుడు న్యూమరేటర్ లో ఉన్న ఏదైనా నెంబర్ ని డివైడ్ చేస్తుందంటే సో ఖచ్చితంగా అది సో that will be a prime number only. Okay, so 5 is a prime number if it is going to divide a number, so definitely it is a prime number, because the prime number is nothing but the number which divides itself and 1. Okay, so it is divided by itself and 1, that is called the prime number. Here P is the one prime number. You can take 2, 3, 5, 7, 11 up to so on. That prime number divides the order of the group. Okay, then order of the group is also a prime number. Okay, so now claim is nothing but capital G has an element of prime order. Okay, so if you take any group capital G in this format A, B, C, D. Okay, so now we have to prove that out of finite number of elements, one element. Okay, for example, if you take one element, that order of that element is equal to small n. Okay, that order of that element is equal to P. A power P is equal to small e. Okay, that order is equal to prime number. We have to show that one. To show that one, okay, so now this theorem we are going to use, we are going to prove by using principle of mathematical induction, PMI. Okay, so that's why I am taking the first of all statement S of n is equal to statement. So we are denoting with S of n. S of n is equal to capital G is a finite abelian group and P is a prime number that divides order of capital G. Then G has an element of order P, where small n. Okay, so wherever you are going to substitute small n value is greater than or is equal to 2. Why? Because so we are going to prove this theorem on the prime numbers. Prime number starting with 2 only. 2 is the only even prime number. Okay, prime number start with 2. So that's why we are taking n greater than or is equal to 2. If you take n is equal to 1, what is that meaning? The total number of the elements in the group is equal to 1. That is only identity element only exist. Okay, so identity element singleton small e will only exist. Okay, so then the proof is trivial. Whenever you have the singleton e, For every theorem the proof is trivial. So that's why we are starting with n is equal to 2. So now by using principle of mathematical induction, factor group and properties of cosets, we can prove this theorem. Okay, so here principle of mathematical induction, we are going to use the second principle. Okay, there are two types of mathematical induction principles. The first one is the in the case 2 we have to assume for n is equal to k, it is a true. In case 3 we have to prove that for n is equal to k plus 1. Okay, for n is equal to k plus 1 we have to prove. That is the first method. In second method, okay, in case 2 we have to use the given statement, we have to assume the given statement is true for k less than n. Okay, where k is the s of k. Okay, so k less than n we have to assume. In case 3 we have to prove the given theorem for k is equal to k. Okay, for k is equal to n. So that is the here in this theorem we are going to use the second mathematical induction principle. So by using mathematical induction, so we are starting with case 1. In case 1, if order of G is equal to 2, our intention is we have to prove that G has a prime order. Okay, so first of all we have to take the order of the group G. So I am starting with if the order of the group G is 2. Okay, if you take the order of the group G is equal to 1, then G is equal to singleton small u only. If you take order is equal to 1, then the elements of capital G is equal to singleton u only. Then no need to prove the theorem. That solution will exist trivially. Okay, so therefore that's why we are starting with order is equal to 2. If you take order is equal to 2, what is that? Mod G is equal to small n is equal to 2. So then the elements of that group, okay, 2 elements are there. Okay, out of 2 elements definitely one element should be identity. సో మనం ఇంట్రడక్షన్ లోనే చదువుకున్నాం స్టార్టింగ్ లో, ఏవైనా 2 ఎలిమెంట్స్ తీసుకుంటే గ్రూప్ లో అందులో ఖచ్చితంగా ఒక ఐడెంటిటీ ఎలిమెంట్ ఉండాలి, ఒక ఇన్వర్స్ ఎలిమెంట్ ఎగ్జిస్ట్ అవ్వాలి అని చెప్పేసి. ఓకే, సో ఇక్కడ 2 ఎలిమెంట్స్ ఉన్నాయి. సో అవుట్ ఆఫ్ 2 ఎలిమెంట్స్ వన్ ఎలిమెంట్ ఈస్ ద ఐడెంటిటీ ఎలిమెంట్, దట్ ఈస్ ఏ కామా స్మాల్ ఈ, వేర్ ఈ ఈస్ ద ఐడెంటిటీ ఎలిమెంట్ ఇన్ క్యాపిటల్ G. సో క్లియర్లీ G ఈస్ ఏ cyclic group. Clearly G is a cyclic group. Basically G is an abelian group, finite abelian group. And by noun theorem we can prove, we proved in the previous lectures, every abelian group is cyclic. So that's why from that statement we can write that clearly G is cyclic group. So then G is equal to generated by one element, okay, that is A. So according to the cyclic group definition you can write G is generated by A for small a belongs to capital G. So therefore where order of A is also equal to 2 only. Okay, where why? Because the total group is generated by A only. If you take n is equal to 2, okay, so then order of the element is equal to 2 only. So therefore there exists one element with order 2. So let I am taking prime number, order of the group vachesindi kada, and order of the element kuda vachesindi, group vachesi 2, order vachesi 2. So now I am taking one prime number, that is P is equal to 2, starting prime number, be a prime number, then P divides order of the given group in case 1. So therefore P divides mod G, that implies here 2 is the prime number, this 2 is the order of the group. Okay, 2 by 2 you will get the remainder 0. So therefore S of n is true whenever n is equal to 2. So therefore whenever order of an element is equal to 2, that element order of a group is equal to 2, that order is divided by prime number, then we can say that G has an element small a of order 2. Okay, then you can write a square is equal to small e. That is the meaning of that word. G has an element. Okay, so G ane group lo manaku oka small a ane element undani తీసుకున్నాం కదా, ఆ order of that element is equal to small e. That is the case 1. In case 2, let us assume that the statement S of n is true for k less than n. Okay, so therefore S of k is true for all k less than n. Here k is the finite factors group degree. Okay, sorry, order. K is the finite factor groups order. You can see in the next step. Okay, now case 3, if order of capital G is small n. So now in case 3 we are taking that the order of group G is small n. Then we have to prove that the statement is, that is S of n is true for all n. So since mod G is equal to n, now we have to take one element. Why? Because if you take order of group G is equal to n, and we have to prove that that order is going to divided by one prime number, and our motto is we have to prove that G has an element with prime order. That element I am taking here, small x belongs to capital G, where x naught is equal to identity element. What is the meaning of this one? X naught is equal to E means order of x is not is equal to 1. Okay, so order of x means x power 1 is equal to, also you can write in this format, x power 1 is equal to E. If you write x is equal to E, it gives the meaning of x power 1 is equal to E, then order of x is equal to 1. But if you write x naught is equal to E, then order of x is not is equal to 1, it is greater than 1. So therefore you can write let order of x is q. If x naught is equal to 1, order naught is equal to 1, it is greater than 1. That greater than 1 I am taking as q, where q greater than 1. Here we have two parts. Again we have two parts. First మనం case 3 లో capital G యొక్క order small n అని తీసుకున్నాం. After that we have assumed that one element small x belongs to capital G. ఆ x అనే element కి order ఎంత ఉందని తీసుకున్నాం, q1 తీసుకున్నాం. So whenever you take order of x is equal to q, again two cases arises. So the first the two parts arises. The first part is part A. తీసుకున్న ఆర్డర్ ఎలిమెంట్ కి ఏదైతే ఆర్డర్ ఉందో q అని, if that order is a prime number, మనకు two possibilities ఉంటాయి, either a prime number or composite number or a integer. So therefore part A, if q is a prime number, that means q is equal to p. This q is the order of x. Okay, if that q is a prime number, then order of x is a prime number. Then no need to prove the theorem. Directly you can say that order of the x is a prime number. So therefore G has an element small x that has prime order. Directly you can say that G has an element that has order prime number. So therefore that is taken as equation number 4, x power q is equal to small e. So next in part B, whenever that q, what is the power of the element? Okay, so power of small x is not a prime number. If you take it is a power is equal to prime number, then no need to prove the theorem. So if the power is not a prime number, if it is not a prime number, definitely it is a another number, composite number or integer. For example, if you take q is equal to 8, okay, so if you take q is equal to 8 instead of q is equal to 7, if you take q is equal to 8, then this 8 can be written as product of primes. Okay, that means 2 into 4 you can write, 2 into 4 you can write. Therefore q is equal to 2 into 4. Here ఇక్కడ మీకు ఒక చిన్న డౌట్ కూడా వస్తది, 8 ని 2 into 4 అని ఎందుకు రాసుకోవాలి, 1 into 8 గా కూడా రాసుకోవచ్చు కదా, 1 into 8 గా కూడా రాసుకోవచ్చు కదా అంటే ఆల్రెడీ మనం ఏమని చెప్పాం, q అనేది గ్రేటర్ దెన్ 1 అని చెప్పేసాం అక్కడ. ఓకే, సో దేర్ఫోర్ మనం ఈ కండిషన్ తీసుకోము, ఖచ్చితంగా 2 నుంచే స్టార్ట్ చేస్తాం, 2 into 4 గాని లేదంటే 2 into 2 into 2 గాని తీసుకుంటాం 8 ని. ఓకే, సో దేర్ఫోర్ q is equal to 2 into 4 తీసుకున్నారు అనుకోండి, అక్కడ 2 అనేది ఒక ప్రైమ్ నెంబర్, 4 అనేది ఒక కంపోజిట్ నెంబర్. సో దేర్ఫోర్ whenever you take that q is not a prime number, then ఆ prime number ని we can write into the product of two numbers, q is equal to m into k, where you can take m also. If m is a prime number, then k is an integer. If you take k is a prime number, then m is an integer or composite number, whatever it may be. So I am taking here q is equal to m into k, where m is a prime number, definitely m will be a prime number, then another number, remaining number k is a integer or composite number. So now consider మనం ఒక ఎలిమెంట్ అని తీసుకున్నాం కదా x అనేది, ఆ x అనేది ఎక్కడ ఉంది, ఫైనైట్ ఎబిలియన్ గ్రూప్ లో ఉంది. ఆ ఫైనైట్ ఎబిలియన్ గ్రూప్ ఏంటి, సైక్లిక్ గ్రూప్. ఓకే, సో ఆ x అనేది సైక్లిక్ గ్రూప్ లో ఉన్నప్పుడు కంపల్సరీ ఇట్ విల్ జనరేటెడ్ బై x. ఓకే, సో కొన్ని ఎలిమెంట్స్ ఫామ్ అవుతాయి ఇన్ టర్మ్స్ ఆఫ్ ద సైక్లిక్ గ్రూప్. ఆ ఎలిమెంట్స్ ఎలా ఉంటాయంటే మనకు x పవర్ k. సో నౌ కన్సిడర్ ఆర్డర్ ఆఫ్ ద ఎలిమెంట్స్ in terms of x power k is equal to small m. Okay, so order of x power k is equal to small m. Then you can write in terms of equation mod x power k into small m is equal to x power m into k. Okay, from that above equation, in place of m into k you can write q, x power q. Okay, so therefore from equation number 4, since from equation number 4 you have x power 4 value small e, although q is not a prime number. From equation number 4, you can write that value is equal to small e. With this equation, clearly you can say that order of the elements in terms of x power k, in the form of x power k, have order small m. So therefore, where again small m is a prime number. ఇక్కడ మనం కన్సిడర్ చేసాం కదా where prime is a small m is a prime number అని. So if you take elements in the form of x power k, ఎందుకు x power k లో తీసుకోవాలి? క్యాపిటల్ G అనేది సైక్లిక్ గ్రూప్. సో ఎలిమెంట్స్ అన్ని మనకు ఈ ఫార్మాట్ లోనే ఎగ్జిస్ట్ అవుతాయి. ఓకే, x స్క్వేర్, x క్యూబ్, x పవర్ 4 ఈ ఫార్మాట్ లోనే ఆల్ ఎలిమెంట్స్ జనరేటెడ్ బై x ఓన్లీ. సో దేర్ఫోర్ ఆర్డర్ ఆఫ్ ఆల్ ఎలిమెంట్స్ x పవర్ k is equal to small m, where again small m is a prime number. So therefore G always has an element small x of prime order. Okay, so మీరు ఇలాంటివి ఎన్ని ఎలిమెంట్స్ తీసుకున్నా, not only small x, if you take any type of element, then G has always an element of order small x. Okay, so let us define a subgroup. Okay, so now I am going to define a subgroup that is denoted by capital H. Capital H is equal to generated by small x. It is defined in the form of cyclic group definition x power r, where r is any integer. Okay, r belongs to z. If you clearly observe that, first we took capital H is a subgroup, and by the definition it is a clearly H is a cyclic subgroup. Okay, generated by an element small x. Already that small x, we have also taken that small x belongs to capital G. Same x here we are taking generated by subgroup capital H only. So let order of capital H is equal to q. Already I am taking that order of capital H is equal to q. Therefore order of H is equal to mod H is equal to q. That is taken as equation number 5. Now by one of the noun theorem, okay, so already we discussed the theorem. We have every subgroup of an abelian group is a normal subgroup. Okay, so in finite abelian groups, if you take any subgroup, that subgroup will become a normal subgroup. ఇక్కడ క్యాపిటల్ H అనేది మనం సబ్గ్రూప్ అని తీసుకున్నాం. ఓకే, ఆ సబ్గ్రూప్ అనేది ఎక్కడ ఉంది? ఫైనైట్ abelian గ్రూప్ అయిన క్యాపిటల్ G లో ఉంది. ఓకే, సో క్యాపిటల్ H is a finite cyclic subgroup. It is in the finite abelian groups. Then this capital H will become normal subgroup. Okay, according to the by noun theorem. So therefore, since G is a group and here we got capital H is a normal subgroup, then we can construct a factor group, that is G by H. According to the definition of the factor group, you can write the total number of the left cosets will form a group. Okay, what is the factor group? The total number of the left or right cosets again will form a group. That group is called factor group. So therefore G by H, you can also write right cosets also H into A, where A belongs to capital G. That is taken as equation number 6. ఇక్కడ చూడండి, ఒక సైక్లిక్ ప్రాసెస్ లో ఫాలో అవుతున్నాం. ఫస్ట్ సబ్ గ్రూప్ తీసుకున్నా. ఓకే, సబ్ గ్రూప్ ని సైక్లిక్ సబ్ గ్రూప్ అని డిఫైన్ చేసినాం. ఆ సైక్లిక్ సబ్ గ్రూప్ ని నార్మల్ సబ్ గ్రూప్ అని చెప్పాను. ఎప్పుడైతే నార్మల్ సబ్ గ్రూప్ అయిందో, దెన్ వీ కెన్ టేక్ ద ఫ్యాక్టర్ గ్రూప్. ఇక్కడ మన ఇంటెన్షన్ ఏంటంటే డైరెక్ట్ ఫ్యాక్టర్ గ్రూప్ ని తీసుకునే బదులు ఒక స్టెప్ బై స్టెప్ తీసుకుంటున్నా. ఫస్ట్ మెయిన్ గ్రూప్ ఎలాగో ఉంటది, థీరం మొత్తం మెయిన్ గ్రూపే ఉంటది. ముందు ఒక సబ్ గ్రూప్ ని తీసుకున్నా, ఆ సబ్ గ్రూప్ అనేది సైక్లిక్ సబ్ గ్రూప్ అయింది. తర్వాత బై నౌన్ థీరం ఎవ్రీ సైక్లిక్ సబ్ గ్రూప్ ఆఫ్ అబిలియన్ గ్రూప్ ఇస్ నార్మల్ సబ్ గ్రూప్ అని చెప్పేసాం. సో ఆటోమేటికల్ గా క్యాపిటల్ H అనేది నార్మల్ సబ్ గ్రూప్ అయిపోయింది. సో ఎప్పుడైతే H అనేది నార్మల్ సబ్ గ్రూప్ అవుతుందో, by noun theorem only capital G is a finite abelian group and H is a normal subgroup, then we can define the factor group. ఇలా మీకు చైన్ బై చైన్ కనెక్షన్ ఉంటుంది. డైరెక్ట్ ఫ్యాక్టర్ సబ్ గ్రూప్ అంటే సో పర్ఫెక్ట్ రీజన్ ఉంటుంది. సో దేర్ఫోర్ నౌ ఆర్డర్ ఆఫ్ ద ఫ్యాక్టర్ గ్రూప్. ఇక్కడ ఫ్యాక్టర్ గ్రూప్ ని ఎందుకు డిఫైన్ చేస్తున్నాం? వాట్ ఈస్ ద రీజన్ బిహైండ్ టు డిఫైన్ దిస్ ఫ్యాక్టర్ గ్రూప్ ఈస్, కేస్ 2 లో ఒకటి అజంప్షన్ చేసాం మనం. ఏంటంటే ఈ స్టేట్మెంట్ ఎస్ ఆఫ్ ఎన్ అనేది కూడా ట్రూ ఫర్ ఆల్ k లెస్ దెన్ n అని. ఓకే, ఆ అజంప్షన్ ని ట్రూ చేయడానికి ఇక్కడ మనం ఫ్యాక్టర్ గ్రూప్ ని డిఫైన్ చేస్తున్నాం. ఓకే, సో దేర్ఫోర్ నౌ ఆ k అనేది ఏంటి? ఆర్డర్ ఆఫ్ ద ఫ్యాక్టర్ గ్రూప్. దేర్ఫోర్ ఆర్డర్ ఆఫ్ G by H is equal to mod G by H. సో దేర్ఫోర్ you can write here ఆర్డర్ ఆఫ్ G by H is equal to ఆ mod ని మీరు స్ప్లిట్ చేసుకుంటే mod G by mod H. ఫ్రమ్ ఈక్వేషన్ నెంబర్ 1 you have mod G is equal to small n, and equation number 5 you have mod H is equal to q, n by q. Okay, so therefore mod G by H, order of the factor group, is equal to n by q. Okay, so n by q అనేది less than n. Why? Because ఇక్కడ q is equal to 1 తీసుకున్నారు అనుకోండి, n by q అనేది మళ్ళీ n అవుతుంది. కానీ ఇక్కడ మనకు కండిషన్ ఏంటి? q greater than 1. Here the condition is q greater than 1. Then n by q is always less than n only. ఏదైనా n ని ఒక greater than 1 value తో డివైడ్ చేసినప్పుడు ఖచ్చితంగా దాని వాల్యూ ఏమైపోతుంది, డిక్రీజ్ అయిపోతుంది. సో therefore then factor group g by h is also an abelian group. Why? Because it is also a finite and order is less than abelian group. So therefore capital G is also abelian group with order n by q less than n. Then according to the statement, p divides this factor group also. Why? Because p divides the main group. In case 1 p divides n. Okay, then p also divides this group. Okay, so therefore why? Because it is also an abelian group. So therefore p divides this factor group. Okay, so therefore p divides order of this factor group. So p divides n by q. How you can write this value? Since we have if you have p divides n, for example if you take n is equal to 12, n is equal to 12, that is the order of the group. Okay, ఈ 12 ni now I am writing into the product of primes. Okay, 3 into 4, 3 into 2 into 2. Okay, so now I can write p divides n. That means if you take p is equal to 3, p is equal to 3, then 3 divides 12. Clearly you can write. At the same time 3 also divides. Okay, so 12 by what is the q value here? 2. 3 also divides 12 by 2. What is the 12 by 2? 6. 3 also divides 12 by 2. So in this format you can write 3 divides 12. Okay, where p is equal to 3, q is equal to 2 తీసుకున్నారు అనుకోండి, n is equal to 12. So therefore p divides n by q. That means 12 by 2, 6. 3 divides 6. In this format you have to apply the numbers. So therefore p divides n by q. So since by equation so therefore by equation number 6, whenever p divides the factor group order, then by equation number 6 you can take ah belongs to g by h for a belongs to capital G, such that order of ah is also a prime. Why? Because ఒక ప్రైమ్ నెంబర్ ఇంకొక నెంబర్ ని డివైడ్ చేసిందంటే ఖచ్చితంగా అది ప్రైమ్ నెంబర్ అయి ఉంటది. సో దేర్ఫోర్ ఇక్కడ n by q అనేది కూడా ఏమైపోతుంది అంటే మనకు ప్రైమ్ నెంబర్. సో దేర్ఫోర్ వాట్ ఈస్ దట్ n by q? ఆర్డర్ ఆఫ్ ద ఫ్యాక్టర్ గ్రూప్. మరి ఆర్డర్ ఆఫ్ ద ఫ్యాక్టర్ గ్రూప్ అంటే అది ఎలిమెంట్స్ కి బిలాంగ్ అయి ఉంటది. సో therefore order of ah, what is the ah? Element in the factor group. So therefore ah is also a prime. So therefore that prime number again I am taking p. Mod ah is equal to p. So according to the equation, ఈ ah అనేది ఫ్యాక్టర్ గ్రూప్ ఎలిమెంట్. ఫ్యాక్టర్ గ్రూప్ లో ఐడెంటిటీ ఎలిమెంట్ మనకి ఎలా ఎగ్జిస్ట్ అవుతుంది? e into h is equal to h. We have discussed in the previous lecture. So therefore a power p is equal to small h. Originally order of an element a power e is equal to small e. Okay, here in factor group a power p is equal to capital H, or you can write e into h also. So therefore if you split that LHS part, a power p into h is equal to capital H. Don't apply the power p for capital H, where capital H is a subgroup. మనం గ్రూప్స్ కి సబ్ గ్రూప్స్ కి పవర్ అప్లై చేయలేము, ఓన్లీ ఎలిమెంట్స్ కే పవర్ అప్లై చేస్తాం. సో therefore a power p into h is equal to capital H. Again this equation is in the form of one of the coset property, that is if ah is equal to h, then a belongs to h. Second coset property. Okay, so therefore this element a power p belongs to h. By using that condition a power p belongs to capital H. So therefore after getting this element, what is that a power p? A power p is the element in the cyclic subgroup, where capital H is a cyclic subgroup. That is only the element existing in the a power p something format. Here you will get one doubt. If this a power p is equal to identity, if you get this a power p value is equal to identity, then it gives the original definition for order of an element. Okay, so therefore order of a is equal to p. If this a power p is not an identity element, then you will get another step. So therefore your first step, if you take that element is equal to identity, then according to the definition of the order of an element, mod a is equal to p for small a belongs to capital G. Therefore order of a is a prime, where what is a? A belongs to element in capital G. Okay, a belongs to element in capital G. ఆ a కి కూడా ప్రైమ్, ఇక్కడ ఆర్డర్ మనకి ఏమొచ్చింది? ప్రైమ్ నెంబరే వచ్చింది. ఓకే, ఆల్తో a power p belongs to capital H, ఆ a power p అనేది క్యాపిటల్ H లో ఉన్న స్మాల్ a అనేది మనకు క్యాపిటల్ G లో ఉంది. ఆ స్మాల్ a కి ఆర్డర్ ఎంత వచ్చింది మనకు? ప్రైమ్ నెంబర్ వచ్చింది. సో therefore this place we can clear that if you take any element in capital G, okay, that element has prime order. Or else if you take that a power p is not an identity element, if you take a power p not is equal to small e, okay, then order of a power p is equal to small m, not a prime number where m is any integer. So according to the definition of order of an element, a power p whole power m is equal to small e. If you apply the indices properties, a power p into m is equal to small e, again by rewriting a power m into whole power p is equal to small e, then you will get it is in the form of order of an element. Okay, so then this equation you can write mod a power m is equal to p. Okay, from this equation clearly you can say that order of the element a power m is equal to p, where p is a prime number. So therefore order of an element a power m is also a prime number, that is p. So with this, okay, with these two cases, a power m is equal to a power p is equal to identity element, a power p not is equal to identity element. With these two cases we can conclude that, okay, if you take any element, starting లో x అని తీసుకున్నాం, ఆ x కూడా ప్రైమ్ పవర్ అని ప్రూవ్ చేసాం. మిడిల్ లో క్యాపిటల్ h తీసుకొని ఆ h లో a పవర్ p అనేది ఎగ్జిస్ట్ అయినా ఆ a పవర్ p లో a అనే ఎలిమెంట్ క్యాపిటల్ g కి బిలాంగ్స్ అయింది కాబట్టి, సో ఇక్కడ కూడా మనం ఏమని చెప్తున్నాం అంటే a కి కూడా ప్రైమ్ ఆర్డర్ ఎగ్జిస్ట్ అవుతుంది. ఓకే, సో therefore g has an element small x of order prime. So therefore s of n is true for all n only. The assumption చేసుకున్న కేస్ 2 లో అజంప్షన్ చేసుకున్న పార్ట్ కూడా మనకి ప్రూవ్ అయిపోయింది. So therefore hence by principal mathematical induction, okay, we can conclude that all three cases proved by the given statement. So therefore this is the Cauchy theorem for finite abelian groups. The theorem lo first we take capital G is a group. Okay, so just assume that out of all element one element is there, that element is x. Okay, now we have to prove that order of this group is prime. Okay, small n, if you take n, order of this group is n, and if you take randomly a prime number, that prime number divides n, then what is asking that one of the element in group G, that means x belongs to capital G, then ఆ ఎలిమెంట్ కి కూడా మనకు ఆర్డర్ ప్రైమ్ నెంబరే ఉంటది. సో therefore x power p is equal to also e. This is the concept of the theorem. క్యాపిటల్ G కి ఆర్డర్ ఎంతున్నా ఆ ఆర్డర్ అనేది ప్రైమ్ నెంబర్ తో డివైడ్ అయినప్పుడు ఆ గ్రూప్ లో ఉన్న ఎలిమెంట్ కూడా ఒక ప్రైమ్ నెంబర్ ఆర్డర్ గా ఉంటది. సో దట్ ఈస్ ద theorem. Okay, so I hope you understood this theorem very well. In the next lecture we are coming with another new topic. Technically this theorem is most important. Okay, so for the examination purpose also it is very important. Make a perfect practice, prepare well. Okay, so this is Viresh signing off from Sia Publishers. So until bye, thank you.